Now see here, this numerical actually based on the transformer. A small town with a demand of 800 kilowatt of electric power at 220 volt is situated 15 kilometer away from an electric plant generator at 440 volt, generating power at 440 volt, and the resistance of the two wire line carrying power is 0.5 ohm per kilometer. The town gets power from the line through a 4000 to 220 volt step down transformer at substation in the town. Calculate the power loss in this process and how much power must the plant supply, and characterize the step down transformer. So, these things you have to calculate. So, now see here in the question, power is generated here by the plant is 800 kilowatt. Suppose there is a power plant at this point here, we take power plant, generation is power is generated, that is 800 kilowatt, and now this power whatever is here, and the same power is required by this town. Town requires also 800 kilowatt, and now at the 220 volt, and where is the power is here at 440 volt generated at this volt. The resistance, it is transported by the two wires whose resistance is 0.5 ohm per kilometer, distance is 15 kilometer here. So, at this point the step up is done from 440 to 4000, it means power is transmitted at 4000 volt, and in the substation it is stepped down from 4000 to 220 volt. So, a step down transformer is used at this, and that is here 4000 to 220 volt. So, now there are the two transformer at the power station, that is transformer is the step up, transmission takes place at 4000 volt, at the substation it reaches at 4000 volt and then it is step down. Demand of this city is 800 kilowatt, and here the power is also being generated at the 800 kilowatt here. So, now you have to see here what is the energy loss in this process. So, now see here we can calculate power loss by calculating current. First thing is here flowing through the wire and then the resistance. So, we know that thing there is a two wire line, we know it, and total distance is 15 kilometers. So, total resistance R is equal to, we can calculate 15 into 0.5 into, that is the resistance of this, into 2, that is actually here 15 ohm. We know the power is equal to V into I, power is 800 kilowatt, V is here 4000, it is transmission is taking place at this into I. So, I is equal to here in this case 800 into 1000 divided by 4000. In this case this and this will get cancelled, and that is here 200 ampere. So, the current flowing through the transmission line is 200 ampere. So, we can calculate power loss. So, power loss is equal to I square R, that is 200 into square into R, that means that is coming to you 15 watt here, because here the power loss we are taking per second. So, that will be here 600 kilowatt. So, see here the 600 kilowatt power is lost. So, now what happened in this case? When the 600 kilowatt power is lost, in that case it means the power plant must supply in this case. So, the power supplied by plant should be 800 plus 600 kilowatt, that means that is 1400 kilowatt. So, when the 1400 kilowatt power is actually produced by the power plant, then the substation will be getting the power of 800 kilowatt, because the 600 kilowatt is lost. Now, for this what will be the characteristics of the transformer? So, for that we can characterize the transformer. We know now the power. Power is here, suppose we have got 1400 kilowatt is equal to V into I, that is we can take 200 So, this and this here we can take here. So, V is equal to here 7000 volt. So, the transformer should be used at the power plant for stepping up this voltage is, that is from 440 to 7000 volt, and in the substation that should be here 7000 to 220 volt. So, that is the characteristics of the new transformer used.